What if electric cars could drive for hours without the need for frequent battery recharge? How would this new development shape transportation? To meet the demand for a carbon-free environment in 2035, the United States is designing roads that can communicate with cars. Yes, using electric signals, of course. What is this new groundbreaking technology? How does it work? And most importantly, what does it mean for the future of transportation? Electric cars are becoming increasingly popular and fast becoming a viable alternative to fuel cars. The market value of electric vehicles has skyrocketed from 4 to 14% of the total vehicle sales globally. The challenges faced by electric vehicles include the need to frequently recharge before taking on longer destinations, the lengthy time taken to recharge, and the most worrisome part, finding a charging station. Because EV charging stations are fewer than gas stations. In 2019, they were up to 87,000 EV charging stations in the US. However, studies have shown that the US will need at least 8 times more EV charging ports by the year 2030 to accommodate the number of electric vehicles that will hit the road. The US, under Biden, allocated a whopping $7.5 billion to build more EV charging stations for more flexibility. However, these Level 2 stations will only provide as much as 25 miles of range in 1 hour, which isn't a lot for long distance. But there's an innovation for the operation of electric cars, and it first launched in Sweden and is going global. This EV charging alternative will eliminate the need to stop and recharge before driving. This innovation is called electric roads. Imagine a modern road designed with electric fields that wirelessly charge your EV as you drive. Every road is connected to the grid and transmitting at the same time, and electric vehicles on the road can charge on motion as long as the compatible device has been installed. Sweden is the first to develop the world's first electrified road, while the US and other countries are currently exploring the design. The city of Detroit launched its first electric road, which was tested at the quarter-mile segment of 14th Street. And according to the Michigan Department of Transportation, this area is dedicated to testing the technology until it is perfected and ready to launch publicly in a few years. So, how do these electrified roads work? Much like one of those smartphones that can charge wirelessly with the aid of a transmitter when placed on top of a wireless charger, the electric vehicle also has a similar mechanism. The vehicle itself will carry a receiver that will allow it to maintain a magnetic field with the electric road. Although electric vehicles do not currently carry any receiver that will enable them to charge on these roads, as time goes on, these devices will be developed and installed to allow EVs to wirelessly power themselves on electrified roads. This technology is not limited to cars alone. Other vehicles such as buses, trucks, and vans are included. To put things in perspective, electric roads, or e-roads, are specifically designed pathways in the form of electric rails, carrying conductive elements and a significant charge, embedded on roads, highways, and other routes. As electric vehicles move on these roads, their receivers connect with elements on the roads, allowing the transfer of energy from the supercharged electric road to the vehicle's battery. The concept of e-roads is to create a consistent and efficient network of roads that support electric cars, keeping their batteries charged for all distances and routes, ensuring that the vehicle battery does not run out. This concept is known as conductive charging. Here's an even better illustration. Imagine an electric vehicle carrying a metal strip directly underneath. As the vehicle drives along an electrified rail strategically embedded in the road, the metal strip underneath the car connects with the electrified rail on the ground, allowing a continuous charge as the vehicle is in motion. Another brilliant method of conductive charging is where each electrical road has special devices constructed or implanted under the roads. These devices send an electric charge upwards, which is received by the coils underneath the electric vehicle and sent directly to charge the battery. This method does not require any contact between the receiver of the EV and the electrical road itself. It is a more flexible method and ensures that the battery is still charging, even if the driver isn't directly following the patterns laid out on the road. Typically, electric cars have to rely on battery types, capacity, and sizes. But with this innovation, the battery type would matter less, even though you still need a good battery for longevity. While the main reason for the electrical roads is to charge the batteries of electrical cars in motion or parked, there are also other functions that the road serves, such as ensuring safety and efficiency of the process. Electrical roads are designed for compatibility with any form of electrical vehicle, making it a diverse solution for both existing vehicle designs and other future designs that are yet to come. This is probably the best time to innovate when constructing roads, as many of the roads currently need rehabilitation and reconstruction. The big budgets set aside for the construction and repair of major roads and highways can easily include the electrical fields on the roads, as they will serve as assets in years to come. However, electrical roads are not cheap and will come with a hefty budget. A company known as Electrion is the pioneer of the electrical road technology. The company estimated that a mile of electrical road would cost about $1.2 million for high-volume construction, while reconstruction of a mile of road can cost anywhere from $1.5 to $11 million, depending on the complexity of the project. Places that are heavily populated or already have infrastructure may be a bit more challenging to overhaul. It may not be feasible to electrify every single road, so there are specific target areas that will have higher priority. Areas of high traffic, streets, intersections, and commercial locations. In rural areas, there will likely be sparse distribution of this technology due to the low population, but there will likely be spaces, such as charging deserts at specific locations, to allow travelers to benefit from it as well. Companies like Electrion are changing the world through dynamic charging, which will greatly outrun static charging and even help major transport companies that have to constantly buy large-capacity vehicle batteries for their operation. What are the challenges faced in the design and development of electric roads? No project is without its challenges, and this is also the same for the electrical road project. The first challenge is that they are super expensive. Secondly, installing and maintaining them would require some time and resources, not to mention that they would likely disrupt traffic during installation, especially on major high-traffic roads. Research estimates that the installation of the inductive system on a 100-meter road would take about 3 weeks, while a conductive overhead channel might take about a month to install every 10 kilometers. This challenge could be minimized if the installation date corresponded with planned general maintenance for the roads and alternative routes provided for commuters. How do extreme weather conditions affect electrical roads? There have been speculations that electrical roads may be disturbed by weather conditions, such as heavy snow covering the ground surface. However, various stakeholders have come out to affirm that there is no issue driving on an electrical road despite heavy snow. The conductive electrical track will simply heat up and dissolve the snow in the tracks, providing a way of passage. Similarly, when cars with chargers drive on the tracks, they also contribute to clearing the snow from the tracks, so there is nothing to worry about. Numerous tests have been conducted in line with safety measures, and the aim is always to ensure that electrical roads solve the problems that they were designed to solve with maximum safety. What is the future of e-roads, and what can we expect? Electric roads are the solution to uninterrupted travel and the convenience of longer trips using electric vehicles. With the charging systems of e-roads, there will be less pressure on resources such as lithium-ion and cobalt, which are major elements in the manufacturing of batteries. E-roads will offer a permanent and sustainable alternative to fuel cars, eliminating them from the market in years to come and helping to achieve zero CO2 emission from automobiles in years to come. The age of fossil fuel cars is slowly coming to an end, and the electrical road is the first step to achieving this. With the recent design and construction of smart cities in various locations, such as Arabia, India, Italy, and others, there is also a dire need to create a CO2-free environment, and this can be made possible by eliminating cars that use fossil fuel and replacing them with EV and electric roads. With the emergence of AI technology, it is also possible to develop intelligent roads that can both charge and autonomously control the vehicle. Roads can communicate with vehicles to decongest traffic and improve the experience of the driver. Electric roads are the future, and it has begun. What do you think about this innovation? Will electric roads end the use of fossil fuel vehicles? Let us know in the comments. If you enjoyed this video, be sure to like, subscribe, and turn on notifications so that you do not miss out on the latest cutting-edge technology. That's all from us, and we'll see you in the next video.